In this video, we're going to cover the basic form for a hypothesis test for testing mu1 minus mu2 for a large sample. So the basis for this is based off of our d0 value, so d0, where d0 is the hypothesized value for our mu1 minus mu2 value, and this is often just set to 0. So if we want to see if there's no difference between the mu1 and mu2 values. So we have the three different hypothesis tests, just like we've seen for all of our different hypothesis tests. So for each of these, we have our h0 value, where it's mu1 minus mu2 is equal to d0, and that's the same null hypothesis for each of our different tests. We then have our alternative hypothesis, where mu1 minus mu2 is less than d0, not equal to d0, or greater than d0. And that's all based off our simple test statistic. So this is just the z statistic that we've used before, with the simple change for the formula, where instead of having x bar minus mu, we have our x bar 1 minus x bar 2, and that whole value is subtracted from d0. So we're trying to see how it compares to our d0 value. And then we divide by our sigma sub x1 bar minus x2 bar, where we have this formula over here for our sigma sub x1 bar minus x2 bar, and it's equal to the variance of x1 divided by n1 plus the variance of x2 bar divided by n2 and the square root of that. Or if we don't have sigma 1 squared and sigma 2 squared defined, we can just substitute in our s1 squared and s2 squared values. And then we have the same rejection region that we've seen before. So we reject if z is less than negative z alpha, if absolute value of z is greater than z alpha over 2, or if z is greater than our z sub alpha. So it's the same hypothesis test that we've seen before when we were testing for our mu values, but in this case we're just subtracting first and treating that as our x bar value and d0 as our mu value.